Hi, welcome to this platform for Sensor Academy, either the YouTube channel or the Facebook page. If it is the first time on this particular YouTube channel, consider subscribing, turn on the notification bell in order to get notified when next I post any video. If you're watching this on our Facebook page, kindly leave a comment, share the video, and tag the 2024 GCE candidate anticipating for the exam after next week. In today's tutorial, we're only going to consider a very guaranteed and highly anticipated topic, which is going to be under light. Our discussion is going to be in Science Paper 1, particularly physics, trying to prepare adequately for the 29th July exam. So the question is of a 2023 GCE exam, and it says figure B6.1 shows a ray of light traveling from glass to air at an angle. The refractive index of glass is 1.52. So when we talk about light, it's either we can have that is the reflection of light, which is the bouncing back of light when a ray of light approaches or touches a shining surface. We also have what we call the refraction of light, which is the bending of light when a ray of light is traveling from a less dense medium such as air to a denser medium such as water or glass. In this instance, the direction is vice versa. It says glass to air, and glass is more denser than air, which simply means we are going to have total internal reflection. So total internal reflection occurs usually when a ray of light is traveling from a denser medium to a less dense medium, causing the angle of refraction to be 90. So the angle of refraction is this one. This is the ray of light. It's supposed to bounce back, that is refract towards that is normal. But because it is coming from a medium which is containing that is glass or water, we're going to find that it will not be able to refract the same way it's supposed to be. Instead, it will be totally internally reflected, that is to that one. So in this case, we're going to find that when this one is refracted, it's going to form a 90. And then this angle which is here, it is now the critical angle. So define critical angle. The critical angle is the angle of incidence, which is formed when the refraction angle is 90 degrees. The critical angle is the angle of incidence created when the angle of refraction is 90. Usually when a ray of light is traveling from a denser medium into a less dense medium. So I'm going to say this is the angle. This is the angle of incidence created when the angle of refraction is 90 degrees. So we can also say the critical angle is the angle of incidence which causes the angle of refraction to be 90. So moving on, B. Calculates the critical angle in figure B6.1. So since we have been given the refractive index, the refractive index is drawn from the comparison of the sign of the angle of incidence to the sign of the angle of refraction. Now, under an instance where we've got that is total internal reflection occurring, we're going to say, so this one is B, so we're going to say the refractive index is 1 over that is sine critical. So we have that is the refractive index. So the refractive index is 1.52, which is equal to, so we're going to have 1 over that is sine critical. So I'm going to say over 1. Then we're going to cross multiply. So I'm going to say 1.52 times sine c. We're going to have 1.52 sine critical equals to 1 times 1. It's going to give us a 1. So here we're going to divide with that is 1.52. Even here 1.52. So this and that cancels. So here we're going to have sine critical equals to, when 1.52 is divided into a 1, when we use a calculator, it's supposed to give us 0.6579 with some other values. Remember, we are finding that is the critical angle, hence this trigonometric ratio should cross over. So critical angle is going to be, when this crosses over to this, it becomes sine inverse of 0.6579. So C is now going to be, when you use the property of special angles, this one is supposed to give us a 42 degrees. Maybe for some instances, it can give us, that is 41.1 degrees with some other values. So as you will be watching the video, you can be able to confirm the values and try at least to see how I rounded off. So the critical angle is 41.1 degrees. Then for C, state two conditions for total internal reflection to occur. State two conditions for total internal reflection to occur. The first one is that the angle of refraction should be 90 degrees as visibly observed from the diagram. Then thereafter, the ray of light should be traveling from a denser medium into a less dense medium. As observed, this ray of light, a ray is a path taken by light from its source to where it's heading to. So this ray of light is traveling from glass into air. So as it is traveling from glass into air, it's going to refract, or it's going to internally reflect it back into the medium. So one, the angle of refraction should be 90 degrees. The ray of light should be traveling, or should be moving from a denser to a less dense medium. So we're going to say the angle of refraction should be 90 degrees. The ray of light travels from a denser to a less dense medium. So the angle of refraction should be 90 degrees. The ray of light travels, or should travel, from denser to a less dense medium. Lastly, D. Give one application or use for total internal reflection. Total internal reflection is used in optical fibers as a form of telecommunication and data transmission. So we're going to say it is practically used in optical fibers. It is used in optical fibers as telecommunication and for data transmission. So these are the answers to the question on B6 from 2023 GCE exam. I hope you find this video very much beneficial and that you can grab a paper and relate the same to some of the previous questions that have come in the past papers that are maybe open to the public, like 2022, 2021. Make sure that you subscribe to this YouTube channel and tag that GCE candidate, having to see to it that this video may be able to play a role in terms of acting as a benefit and as a guarantee that if such a topic was to arise in an exam, then definitely it will be all to your advantage. This is your tutor, Mr. Sensor, from Sensor Academy School of Tuitions. Till in the next video, for now, it's a very goodbye. Stay focused.